All right. Hello, everyone. So this is a recording of a presentation that was done at SOFT 2025 in Portland. So this was part of the workshop on data analysis that I was lucky enough to co-chair with Sue Baring from San Francisco. And this presentation is on data analysis tools. So nothing to declare here. All right, one of the questions that I regularly get asked is, well, which software is the best for data analysis and visualization? Like if I want to invest time in learning something or in buying something, which one should I look into? And as with several things in life, unfortunately, my answer is it depends. And it depends on what needs to be done. It depends on how often do you need to do it. Like, do you need to do it just this one time, and then you can expend a bit more manual labor because it's just a one-off thing, or is this something like a report that you have to run every week, and then it makes sense to sort of automate it to put more time because in the end you'll be saving some work. What is your budget? If you're in a public forensics lab or in a university lab, your budget is probably not that high. But on the off chance that you have a good budget, yeah, what's your budget here? What's your budget in terms of time? Also, how much time do you have to put into doing your data analysis and building your data processing? So all of these are going to influence which software really you should choose for data visualization and data analysis. Oh yeah, also what are your skills and interests? Because if you're interested in coding, that's one thing. If just opening Excel makes you want to puke, quite another thing in terms of choosing your software. So what I want to do in this presentation is sort of lay out a map of the different software, what are their strengths and weaknesses, so that you can orient yourself in terms of the different options that are available out there and pick the best for your context, your data analysis, your laboratory. So let's start with the lighthouse of reassuring Excel. So of course, this is what the interface looks like. I think we're all familiar with it, and that's exactly one of its strengths. The first one being it's cheap. And it's cheap because usually it's included with the computer with Office 365. And so most of us have either Excel or another, spreadsheet analyzer that is available to us. So usually cheap. And also, I said it's reassuring. We all know it. It's intuitive, right? Um, Sometimes though you gotta wonder, is it really intuitive or is it just well known? And so we feel like it's intuitive because we've been working with it our whole lives. But in any event, you can orient yourself well in the software, sort of have an intuition of where to click. So yeah, that's good. Data visualization in Excel is okay, but it's not the best one. Other softwares have way better data visualization, and you can improve on the basic data visualization that Excel offers you to do something that's actually quite good. But as a basic general rule, kind of meh. Statistics. Um, in Excel is okay. You have several formulas that are included sort of in the basic formulas, but if you want to go further in your data analysis, do statistical testing, ANOVA, F-test, distribution testing, then it gets a bit hard to work with Excel if you can even do it at all. Low automation, although this is getting better by the year, really, with Excel as they integrate like Power Query and other automation tool. But generally speaking, lots of manual labor. It has a large community, of course, because as I said, everyone has it almost. So you can generally find the answers you want on the internet, so that's good. Just a few comments on Excel, though. You need to beware of its tendency to just transform everything into a date. Um, yeah, so there's this small meme here that really illustrates how it has a tendency to flip everything into date, and this has real impact, in real life. One paper estimated that 1 in 5 genetic papers contained error due to Excel converting the genes names to date, rendering the data useless. That's quite a lot, right? It has an impact in real scientific, um, scientific data and papers. There is a maximal size that you need to be aware of. So roughly 1 million rows and 16,000 columns for the XLSX file format. You might be saying, I'm never going to reach that, but sometimes this is, I'm going to say, quite a surprising thing when it happens. There was a story that scientists in the UK started their COVID database in Excel. And yeah, quite quickly reached the maximum size for an Excel spreadsheet, and were sort of caught off guard by that. So not an issue until it's an issue. Okay, so we move away from Excel to our next type of software, which are the point and clicks. Okay, so these are software point and clicks where, similarly to Excel, you're going to go and click on different buttons to achieve the data analysis you want or create the graphs that you want, right? So there's no coding involved. It's really clicking on things to give commands to the software. So this here is Prism, right? GraphPad Prism. So it gives you sort of an idea of what the interface is for that software. And yeah, here you have Minitab, which is another point and click software. So yeah, Prism, Minitab are two examples of point and click softwares. There are other ones, right? But these are some of the most common ones. Okay, one disadvantage is that these software are not cheap. GraphPad Prism is not too bad, $500. Minitab is more pricey. They're in the more intuitive realm, I would say, so very similar to Excel, right? You might need some time to familiarize yourself with the different commands, but it's quite intuitive to go and click on stuff to accomplish different stuff. Data visualization is really good with Prism. You can do really slick graphs, really slick presentations. That's really nice. Minitab is really disappointing for a data analysis software, and especially a pricey one like that. So maybe if your goal is data visualization, that's not such a great option. What's really nice with these software, though, compared to Excel, is they have pretty good stats, like not 100% complete, but really good stats. Unfortunately, there is not really an automation capability in either software. It's rather limited. And I think the reason for that is Prism was mostly built as a software to work in universities, right? And so you buy that software, you have your little research project, you analyze the data, you put out the graphs for the paper, and then you move on, right? So there's not this sort of framework of, oh, I'm going to analyze data over and over and produce the same report over and over, right? So yeah, no or little automation. The open community is quite limited for both software because, because they're paying software. Not everyone has that, and so it's a bit more limited in terms of what you're going to be able to find as an answer on internet. So are the point and clicks good or not? Well, again, it depends on what you want to do, right? If you want to be supported in doing deep statistical analyses and do shiny graphs for publication or reports, like one-time publication or reports, Yeah, they're great software, okay? If you want to take raw data, clean it up, and store it into databases for further use, these are not the software that you're going to want to go with, okay? All right, so let's move away from point and clicks and we'll go over the minds of fancy software. Okay, what are my fancy software? Here I have Tableau's interface. And here I have Power BI interface. Okay, so these are two pretty up there software. They're going to help you build dashboards and all of that sort of fancy stuff and even publish those dashboard online. It's pretty cool. Okay, again, pretty expensive software. You're gonna talk, all of these software now have how many ever plans that are available, and then mostly now we're in the realm of software as a service, and so usually it's like, oh, you pay that amount for a year, but then it depends on like 20 other different factors. So anyways, pretty expensive. That said, for Power BI, you might be lucky and it might be part of your Office 365 subscription, depending on where you work. So definitely check that out. There is a definite learning curve for both software, both for Tableau and for Power BI. And the data visualization, as we saw, is pretty slick, especially if you want to do interactive dashboard. It lends itself to that really well, so that's pretty cool. In terms of statistics, it can do some, but it really does descriptive statistics only. So the average, the standard deviation, all that sort of stuff. But if you want to do, for example, distribution testing, then that's not the software for you, but you can boost either software with a bit of coding. So both can be interfaced with R or Python, if I'm correct. The automation here is absolutely awesome. That's actually why it was built. I mean, Power BI is business intelligence, right? So it was built to take some data sources in your company and have dashboards for business intelligence and to automate those steps of gathering the data and displaying the data. So yeah, awesome automation here. Growing community in both cases. Okay, so point and clicks, are they good or not? Well, if you want to develop automated dashboards, and have something that goes into your existing data sets in Excel or other types of databases, and automatically produces dashboards, then yeah, that's what you're looking for. And I mean, Power BI. BI stands for business intelligence, right? So that's what it was designed for. It was designed to take different information and put it in a format that led you to conclusions about your business and to improvements to do and so on. So yeah, business intelligence. If you want to do deep statistical analyses and prepare single-use graphs for paper or for conferences, this is not the tools that you want to use, right? Okay, we leave the minds of fancy software and we go to the mountains of mysterious coding. And here is an interface for RStudio. But yeah, you have different coding languages. I'm going to talk here specifically about R and Python because these are often used in science. What's great with them? They're free. Free. And yeah, again, if you're a public lab, not a lot of money, this is going to be awesome for you. What's going to be less awesome is that you're going to need to fight it out with IT somewhat, because this is quote unquote an open source thing, especially for R. IT tends to balk at it somewhat. That said, in our lab, we've been able to get IT to sort of approve R&R Studio, and when we want to update, they need to approve the new version that we want to install on the computer, but basically they vet it before they deploy it on our system. And ultimately, you can always make the argument that this is a coding language, right? And if they want to ban coding languages, we might as well not have computers because that's what computers are built on. And if they don't want you to use R, you can always use Python. Python has greater integration with Excel nowadays, so you can even do some Python coding within the Microsoft interface. If they don't want that, there are other languages, programmation languages that you can use. But yeah, probably a bit of a fight with IT in your future. That said, Power BI. I used to think, well, this is a slam dunk in terms of getting it accepted by IT because it's an Office 365 function, right? Turns out we're having some problems right now getting it accepted by IT. Go figure. But yeah, definitely learning curve to any coding language. But I'm gonna say it's been getting better with IA tools, right? So you can be very much supported in your coding by ChatGPT and the likes. Awesome automation, of course. That's what coding languages are sort of built for, that and statistical analysis, especially in the case of R. So awesome automation, you can do pretty much what you want with it. They have slick data visualizations. It's infinitely customizable, and you have the best statistics of all the software I've presented. Well, no, that's not true. I mean, Prism especially has pretty great statistics. But R and Python are unbeatable because it's all there or it's doable, right? You can manipulate the data however you want. So yeah, pretty much unbeatable in terms of graphic and statistics, although it might take you some time to actually achieve it. Packages and libraries make it much easier. When you start coding, you might go, oh my God, how am I going to devise all of these graphs and these statistics by myself? Like, this is going to be way too long. But actually, what happens is that people have built packages in our libraries in Python that have already sort of built up these tools to do the different statistical data analysis or graphs for you. So it makes it much easier. And there is a very, very, very large open community. These are free. A lot of people use it. And so, yeah, you're going to be able to find an answer to your pretty much any problem that you face really easily. Okay, so one thing I do want to clarify because it can be pretty confusing at the beginning when you start get into coding is what is the difference between a coding language and an integrated development environment? So the IDE is the software that you use to prepare and compile your code. And so you speak English and you use Word to write reports. Well, you would code it in R and you would write script in and compile them in RStudio, right? You need to have both to be able to do coding, the language and the tool to write and interpret the language. Other examples would be you are writing code in Python, but you use the VS Code or the PyCharm IDE to write and compile your code. You have plenty of other languages, C++, C Sharp, HTML5, JavaScript, and so on. And you also have a ton of other IDEs. And just to be clear, usually one IDE is going to be able to do several coding language. For example, in RStudio, you can do Python as well. You can do C Sharp. You can do plenty of things. VS Code is also a very generic IDE in which you can code pretty much anything. So yeah, generally the IDEs can do several coding languages. But yeah, you need to have both to be able to do coding. I also do want to mention here that we have a R users group that is actually not exclusive to R because we have members coding Python. So really, it's more of a like nerds who code in forensic toxicology user group. If you want to join us, if you're interested in coding, we don't have that many activities, but we try and meet at the different conferences just to share stories and tips. So yeah, just hit the QR code, fill the form, and join us if you're interested in coding. All right. So what's a summary of all that we said up to this point? Well, so here you have the different types of softwares, Excel, point and click, weird in between fancy software, coding. In terms of price, you're going to want to go probably with R and Python, so the coding ones, or with Excel. These are the cheapest ones. If you're interested in something that's more approachable, more intuitive, then Excel and some point and clicks like Prism and Minitabs are the way to go. If you want to do deep statistical analysis, you're better off with either some point and clicks or coding. If you need to automate some stuff, then that's going to have to be those fancy softwares, Tableau, Power BI, or coding. Although depending on like the depth of automation that you need, Excel again is getting better and better on that. And I wanted to have a few more slides on how you can boost Excel, because as I said, it's getting better and better, and there are more and more tools that are available within Excel that make it an increasingly good data analysis software, really. And yeah, I've been identified throughout the years as like the R lady that wants to do everything in R, but I still use Excel a lot in my practice, and yeah, I'm not dogmatic here. I love R, but I'm not dogmatic about just using that. So anyways, analysis tool pack, good way to boost the basic stats in Excel. So here I just laid out the instruction on how you can install it, and basically it shows up in the data ribbon as data analysis, and when you click on that, you have several more advanced statistical tests that are now available to you. ANOVA, F-test, histograms, t-test, blah blah. So more advanced statistics, but this isn't automatable, so it's all like clicking to do the tests, but it's better than nothing. Recent addition to Excel, the slicers. Slicers are pretty cool. So if you define something as a table, so here you see just a part of my to-do list. But if you define something as a table in Excel by going like in the Insert tab and then clicking on Table, you define something as a table, then you can add some slicers here. And slicers are these here where you can click on the different things to filter the table with it. And you can even do timelines where you can dictate, oh, I want from this month to this month only in the data table. So pretty cool way to handle massive data tables in Excel. What's interesting is it works online, right? There was sort of a similar thing that you could do with VBA coding in Excel, but VBA in the online version of Excel doesn't really work. And so if you're using SharePoint, OneDrive, all that sort of stuff, that's going to be an issue. The slicers do work on the online version of Excel. So yeah, cool stuff to try. Power Query, you can really boost your automation with that. So it's already included within the most recent version of Excel. I'm not going to go too deep in that because I think this is something we're going to touch on in the workshopping part of this workshop, the hands-on part of this workshop. But yeah, a really cool way to boost your automation, identify text, reformat stuff. Yeah. So yeah, if you have any questions, comments, query, feel free to get in touch either by email or different social media platforms.